Welcome back to my channel. Today it's all about the Lewis structure. So in this video, I'm going to explain it. First of all, what is a Lewis structure? A Lewis structure is a visual way to show how the outermost electrons of atoms, the valence electrons, are involved in bonding. These are the only electrons we draw because they are the ones that interact with other atoms. In a Lewis structure, atoms don't give away their electrons, but instead share them to form electron pairs, which creates covalent bonds. We can only make a Lewis structure when the molecule only contains nonmetals. You can find them here on the periodic table. The Lewis structure gives us a simple idea of how the molecule is built. Atoms always want to be stable, and the way they do that is by trying to have a full outer shell of electrons. That's why they bond with other atoms to form molecules. For most atoms, that means having 8 electrons in their outermost energy level. This is called the octet rule. Because this atom already has 4 electrons in its outer shell, we need to add 4 more electrons to fill it. The atom can obtain the additional electrons by forming bonds with other atoms, effectively sharing electrons within a shared electron cloud or communal system. So when atoms bond with each other, they either share, gain, or lose electrons to reach that magic number of 8. In our case, they share their electrons. That's why understanding valence electrons is so important, because they're the ones involved in getting to that full outer shell. Now, why exactly 8 electrons make an atom stable? Honestly, you don't really need to know all the quantum physics behind it right now. Just remember that atoms are most stable when they have 8 electrons in their outer shell. That's called the octet rule. In a Lewis structure, a dot stands for one valence electron. When 2 dots are next to each other, we call that an electron pair or lone pair. A line is equivalent to 2 dots and represents either a lone pair or a bonding pair of electrons. That's a covalent bond. So, when a line connects 2 atoms, it represents a bond. But when a line or pair of dots is not connected to another atom, it's called a lone pair or electron doublet. It's important to note that an atom can form a maximum of 4 bonds. That's because one bond equals 2 shared electrons, and most atoms can only fit 8 electrons in their outer shell. So once an atom already has 4 bonds, which makes 8 shared electrons, it can't form any more. Therefore, if an atom has 5 or more valence electrons, it doesn't mean it will make 5 bonds. It will make 3. Each time an electron is added to a shell, we place it in one of the 4 directions, like compass points. After 4 electrons, each direction is occupied. Any additional electrons are then paired with existing ones in the same direction, forming electron pairs, also called doublets. Now let's have a look at how we need to make a Lewis structure of a molecule. All we need is the number of valence electrons of the elements used in the Lewis structure. So how do we find that? We will need the periodic table of the elements. This will give us a clue about the number of valence electrons. You don't actually need to write out the whole electron configuration to find the number of valence electrons. There's a much easier way. Just look at the element's position in the periodic table. For the main group elements, that's groups 1 to 2 and 13 to 18. The group number tells you exactly how many valence electrons the atom has. So, elements in group 1 have 1 valence electron, group 2 has 2, group 13 has 3, and so on, all the way up to group 18, which has 8 valence electrons. The only exception is helium. It's in group 18 but only has 2 valence electrons, because it only has 1 shell. This shortcut is super useful when you're drawing Lewis structures, because you can instantly know how many dots to draw around the element symbol. Alright, time for some examples. I'll go through a few to help you get the hang of it. We'll start with 2 simple molecules that are easy to understand, perfect for beginners. Then we'll look at 2 acids. These are a little more complicated, but there are some tricks to make it really easy. And finally, we'll end with 2 more difficult molecules, just to challenge ourselves a bit and see how all the steps come together. Also, something important to know when working with molecules. In organic molecules, you'll often see carbon atoms, C, bonded directly to each other in long chains or rings. That's because carbon loves bonding. It can make up to 4 bonds and is the backbone of most living matter. Organic molecules can be recognized by the fact that they are composed only of carbon, hydrogen, and oxygen, and sometimes a few other nonmetals. Inorganic molecules rarely have this kind of chain structure with repeating atoms of the same element. They're often smaller, simpler, or made of different types of atoms bonded in various ways. Inorganic compounds include everything else, such as salts, minerals, acids, and metals. All right, let's get into it. Here come the examples, and feel free to draw them with me on paper so you can really see how it works. The first one is the most basic one, H2, and it consists of two hydrogen atoms. First, we need to check which atoms the molecule consists of. In this case, it only contains hydrogen atoms. We can already place the two hydrogen atoms next to each other. It doesn't really matter how you position them, just make sure they're not too far apart. Then we need to look at the periodic table to see how many electrons hydrogen has in its outer shells. We can see that hydrogen is in group 1, so it has one valence electron. This means we just need to place one dot next to each hydrogen atom. Then, we simply draw a line connecting the two dots, and that's it. The Lewis structure of this molecule is complete. It wasn't so bad, was it? Next up we have CH4, or methane. So again, we first need to check which atoms the molecule consists of. In this case, we see that the molecule consists of carbon and hydrogen. In our periodic table, we find that hydrogen has one valence electron and carbon has 4. Now it's a little more challenging to make the Lewis structure. When you have different atoms in one molecule, it can be tricky for beginners to decide how to place them correctly. A good rule of thumb is to put the atom that can form the most bonds in the center. The atom that can form the most bonds is the one with the most unpaired valence electrons. In this case, it's carbon. So we place carbon in the center and the hydrogen atoms around it. After that, we place 1 dot for each hydrogen and 4 dots for each carbon. Just like in the first example, we then connect the dots with lines, and that's it, we're done. These were the easy ones. Let's have a look at some more challenging ones. Next up, we have HNO3, or nitric acid. So again, we first need to check which atoms the molecule consists of. In this case, we see that the molecule consists of hydrogen, H, nitrogen, N, and oxygen, O. In our periodic table, we find that hydrogen has one valence electron, nitrogen has 5 valence electrons, and oxygen has 6 valence electrons. Now it's a little more complex to make the Lewis structure because we have 3 different kinds of atoms. Just like before, we use the rule of thumb. Place the atom that can form the most bonds in the center. In this case, that's nitrogen, since it has 5 valence electrons and can make up to 3 bonds. Also, when drawing the Lewis structure of an acid, a molecule with an H at the front of it, start by placing the atom that can form the most bonds in the center. Next, arrange the oxygen atoms around it. The hydrogen atoms are not connected directly to the central atom, but instead are bonded to the oxygen atoms, typically forming OH groups. If you don't have any oxygen atoms, just draw the hydrogen next to the central atom. So we place nitrogen, N, in the center. Then, we arrange the 3 oxygen, O, atoms around it, and the hydrogen, H, will be connected to one of the oxygens, not directly to nitrogen. Here's how we distribute the electrons. Place 1 dot for each hydrogen, 5 dots for nitrogen, and 6 dots for each oxygen. When you need to place more than 4 dots, you need to begin to make lines like this. These lines actually are lone pairs. Then we connect the atoms with lines to form bonds. One single bond between N and one O, and this O is bonded to H, forming an OH group. One double bond between N and another O, and one single bond between N and the last O. This is called a dative bond. It's when one atom, in this case oxygen, doesn't share his electrons, but instead takes in a full pair from another atom, in this case nitrogen. Normally oxygen needs to make 2 bonds, but with a dative bond, it automatically receives 2 electrons with just 1 bond. That way, the octet rule is still satisfied. Keep in mind though, this kind of bonding only happens when there's no other way to complete the structure. And just like that, we're done. Our next molecule is H2SO4, or sulfuric acid. Just like before, we start by looking at which atoms make up the molecule. In this case, we have hydrogen, H, sulfur, S, and oxygen, O. From the periodic table, we find that hydrogen has 1 valence electron, Sulfur has 6 valence electrons and oxygen also has 6 valence electrons now. To build the Lewis structure, we follow our rule for acids. Place the atom that can form the most bonds in the center, which in this case is sulfur or oxygen. But since we know it's an acid, we know that oxygen is placed around a central atom, so we know that sulfur needs to be placed in the middle. Then, we arrange the oxygen atoms around sulfur, and finally, we place the hydrogens on the oxygens, not directly on sulfur, but next to the oxygen atoms like this. Sulfur is special because it doesn't have enough electrons to bind with every oxygen atom. This is a little weird. Well, there is a solution. This is what we call a dative bond. But I already informed you about this type of bond, also called a coordinate covalent bond. It is a type of covalent bond in which both bonding electrons come from the same atom. The other two oxygens form single bonds with sulfur and also carry a hydrogen each, forming two OH groups. And that's it. The Lewis structure for sulfuric acid is done. Now, let's explore the last Lewis structure we will do. It's the one of CH3COH, commonly known as acetic acid. This molecule contains carbon, C, hydrogen, H, and oxygen, O, atoms. Carbon has 4 valence electrons, hydrogen has 1, and oxygen has 6. To begin, we identify the basic structure of the molecule. It's important to know that this is an organic molecule. You can see this due to the largeness of the molecule and the carbon and oxygen present. Acetic acid has 2 carbon atoms. One belongs to a methyl group, CH3, and the other is part of a carboxylic acid group, COH. The methyl carbon forms single bonds with 3 hydrogen atoms and is connected to the second carbon since it's an organic molecule. The second carbon is at the center of the carboxylic acid group. It forms a double bond with 1 oxygen atom and a single bond with another oxygen atom, which in turn is bonded to a hydrogen. That's it for today. Hope you picked up something new. If you've got any questions, feel free to drop them in the comments. Don't forget to like and subscribe if you want to see more content like this. Catch you in the next one.